So let's find the tangent line to this parametric situation when t is equal to -4. Let's be very organized, and let's start by saying, I know if I'm going to find a tangent, I need a point, and I need a slope. So let's start with the point first. How am I going to find the point? Well, I'm interested in what is x's value when t is -π/4. And that's going to be what is secant squared of -π/4. And then I go over here and I draw my reference triangle. Let me be more consistent about my drawing of my reference triangle. Boom, boom, boom. I've got 1, 1, root 2. Secant is hypotenuse over adjacent. So secant of π/4 is root 2. I need to know whether secant is positive or negative at π/4. All students take calculus. -π/4 is in the fourth quadrant, where cosine is positive, so secant is positive. But it probably doesn't matter anyway because I'm going to square it. So, secant squared at -π/4 is going to be 2. So my x value of my point is 2. Yes?
Why did that include the -1?
Because I totally forgot to put it in, and let me put it in now. -1. Oh! Excuse me. This is going to make for a very interesting recording. Actually, I can edit it out later. I should leave it in, so my future generations can see what a schmuck I am. All right. So this is square root of 2 squared is 2. 2 minus 1 is 1. Okay, so the x value is 1. How about the y part? Y of -π/4 is equal to the tangent of -π/4. π/4 has a tangent of 1, and in the fourth quadrant, tangent is negative. So the y value is -1. Now I've got my point. To complete the tangent line, I need a slope, and the path to the slope is through the derivative. So let's calculate the derivative dy dx, knowing that in parametric land, it's found by taking dy dt and dividing it by dx dt. So what is the derivative of y? I believe that's going to be secant squared t. What is the derivative of x? Okay, drop the power down. Leave the inside the same. Lower the power by 1. And then multiply by the derivative of secant, which is secant tangent. And so what do we end up getting? Well, I got secant squared on top, but we got 2 secants on the bottom. I think all that cancels out. It looks like I end up with 1/2 cotangent. Check my algebra, please. I feel like I've made a mistake. All right. So, what is the, let me be more particular. Let me tell you what I'm going to try to do and how I'm going to do it. If I want to find the slope then for this tangent line, it's going to be the value of this derivative when t is equal to negative pi over 4. 1/2 of the cotangent of negative pi over 4. Okay, back to my reference triangle. See, cotangent is adjacent over opposite. 1 over 1. Cotangent is going to give me a 1. That's how that 1/2. Is cotangent positive or negative in the fourth quadrant? Well, cotangent and tangent have the same sign, so it's going to be negative. So 1/2 there, and then cotangent of negative pi over 4 gives me a negative 1. So the derivative at time negative pi over 4 ends up being negative 1/2. I think I have all the elements I need then to write the equation of the tangent line. And that is y is equal to the slope times x minus the x value, which was right here, 1, plus the y value of negative 1. The book likes to distribute this through, so we get negative 1/2 x plus 1/2 plus 1, or negative 1/2 x plus 3 halves. Oh, I've dropped the minus sign. Ugh, I hate when I do that. So does this end up being negative 1/2 then?
Yes.
And are we ready to try to confirm this graphically? Just in case there's a parametric tangent line problem on tomorrow's quiz. Possible. I don't think we're going to get to it today.
Oh, rats.
All right,
Sounds really
let's see if it works out. Yes. Shh, I can't hear your question.
When you got 1/2 t,
Yeah.
how did you pass out the secant t?
Well, I have a secant squared right here. And I got one secant t here and another secant t. So I got a combined secant squared on the bottom as well.
I thought that secant
Negative root 2 squared.
squared, the first one.
2.
Yeah.
Is right underneath that, not squared.
Wait, hold
Oh,
on.
wait, no, that's still one. Sorry, got
That's
it.
it. I dropped the power
Yeah,
down.
I got it, sorry.
Okay, great.
Unless.
So let me put this in parametric mode. Let me clear out the old stuff from an earlier demonstration. All right, let's pop back up. I don't think my calculator could work any slower. And let's put, what's our value of x is secant squared? Okay. So secant squared, how am I going to get that in the calculator? 1 divided by cosine x, or actually t. And I need to square that. I need another set of parentheses to square it. And I need to go back and get a parenthesis before cosine. Oops, I forgot to put it. Forgot to go into insert mode. Cosine. Okay, so there's secant squared. And now I need what? Minus 1 at the end of that. Is that good? Right? Tangent t. Hey, Vicki.
Yeah.
Tangent t for y. And then I'm also going to want to put in my tangent line. And the trick to doing the tangent line is that I'll make xt, and then the equation of the tangent line, wherever there was an x, I'll put a t. So negative point. Oh, boo! Phew. Sorry. I end up covering up parts of my calculator, and it makes me really angry. Okay, there we go. Where was I? Negative 0.5 t minus 0.5. So I think I've got, in the first cell of elements, the curvy part, and the second one, the tangent line. Yes, EJ? The bottom one I put in, negative 0.5 t minus 0.5.
Yeah.
It is my tangent line equation. Except every place I see an x, I put a t, because I'm making x equal to t. Okay, let's try this. What's the worst that could happen, eh? I'm not sure that gives us the entire picture. I'm gonna get a little bit more t's here. I'm gonna go from negative 10 to 10. So it looks like the curvy part is this sideways parabola. And then the tangent line seems to be running down along the side there. Actually, probably not a parabola. Probably not. But does it look like a tangent line? I think we got it. Is that sufficient for problem number 43? Yeah? All right. So I'm going to turn off this recording for 43.
Okay, wait.